Hey guys, in this lesson we would understand how to draw the graph of a rational function that is given in the form of linear over linear, or it's also called ax plus b over cx plus d. That's the general form of writing the rational function. Sketching the graph of this type of rational function requires just one way, and once we get the graph, we can look at the graph to write on its key characteristics. So let's go over the steps. If a function is of this kind, the first step is find the horizontal asymptote. In this particular type of function, the horizontal asymptote would be always equal to a over c. Second step is find the vertical asymptote. We know vertical asymptote is the value of x that we get when we put denominator equal to 0. So when we put the denominator cx plus d equal to 0, the vertical asymptote that we would get will be negative d over c. Step number 3 is find the x-intercept. To find the x-intercept, we have to put the numerator equal to 0, and the numerator is ax plus b. When we write down this general expression ax plus b equal to 0 and solve for x, we get x equal to negative b by a. Therefore, the x-intercept is negative b over a. Next, when we have to find out the y-intercept, all we have to do is just put the x value equal to 0, and we'll be left with b over d. The next step would be find the end behavior near horizontal asymptote. That would be using table of values, as we have done this in the previous two videos as well. Step number 6 is find the end behaviors near vertical asymptote using table of values again. And the last step is sketch the graph using all the above steps. Let's understand this with an example now. Let's say we are given an example, x minus 4 over 2x plus 5. We know this is a linear over linear type of question. So step 1, that is the horizontal asymptote, would be equal to y equal to a over c. We know a here is going to be no number as 1, c is 2, so it is 1 over 2. Next, vertical asymptote is going to be x equal to, because it's negative d over c, so negative 5 over 2. Step number 3 is the x-intercept. For x-intercept, we have to do negative b over a. Here b is already negative, so negative of a negative becomes a positive. Therefore, x-intercept would be equal to 4 over 1, which is nothing but 4. Step number 4 is y-intercept. Y-intercept, we do b over d, that is negative 4 over 5. So y value is equal to negative 4 over 5 in this case. Before doing step number 5 and step number 6, we would first plot all these points on the grid. So if you're given the grid like this, horizontal asymptote is y equal to half. Half would be somewhat here, so we would make the horizontal asymptote going through y equal to 1 over 2. That is this horizontal line. Vertical asymptote would be x equal to negative 5 over 2, which is negative 2.5. That would be somewhat here. So this is how our horizontal and vertical asymptote would look like. X-intercept is x equal to 4, that is this point. Y-intercept is y equal to negative 4 over 5, that is negative 0.8. That would be somewhat here. Now, since we know these type of graphs are symmetrical graphs, and the graph has to cross through these 2 points, that means the graph should go somewhat like this, and the other side should be like this in order for it to be symmetrical to the graph. But to be more specific, we would complete the steps, that is step 5 and step 6. Step number 5 is end behavior near horizontal asymptote. Horizontal asymptote end behavior is always approaching negative infinity and approaching positive infinity. When we make the table of values, we would have x here and we would have fx here. Similarly, we can make another table. We can take one x value negative 10, other is negative 100, here positive 10, positive 100. The function that we're working on is 1x minus 4 over 2x plus 5. So this is what is equal to fx in this case. Since we have to find out the values of y when x is -10, then x is -100. We'll just put everything in the calculator, subbing in x as -10 in this case. This gives us a 0.933. Similarly, we can solve for y value when x is -100. This would give us a 0.533 value. Similarly, we can solve for the right table. So here x is approaching -infinity and here x is approaching +infinity. F of 10 would be equal to 0.24. And f of 100 would be equal to 0.47. Now using these points, we know when x approaches -infinity, y value is going smaller. However, since it is not going to be able to cross the horizontal asymptote, it will always stay above the horizontal asymptote because horizontal asymptote is at 0.5. So we would notice here that if we keep on increasing these negative x values and solve for fx, it will just be able to go close to 0.5. However, it will not cross the horizontal asymptote. So the end behavior is going to be this way. It will always stay above the horizontal asymptote. When we check the right side, that is this side, on the right side, when x is approaching +infinity, so it is going from +10 to a +100, that means it is going bigger. The y value still approaches 0.5, that is the horizontal asymptote. However, it is below 0.5 because 0.24 and 0.47, both of these values are less than 0.5. So it will approach the horizontal asymptote from the bottom. That's the most we can figure out from the end behavior table near horizontal asymptote. Next is step number 6, where we have to find out the end behavior near vertical asymptote. We just have one vertical asymptote and that is -2.5. So there will be two tables. One is approaching -2.5 from the left side and one is approaching -2.5 from the right side. So heading for this table is x approaches -2.5 from the left side and here it's x approaches -2.5 from the right side. This is x and this is fx value. Here this is x and this is fx. Now when we're approaching -2.5 from the left side, one number that we can take is a -10, so we can save our time. And when we're approaching -2.5 from the right side, here also we can take one value as a +10. So for -10, y value we know is 0.93 and for +10 we know y value is 0.24. The other value that we can take for x is a very close value on the left side and that would be -2.6 and the close value on the right side of -2.5 is -2.4. Let's solve for f of -2.6. When we put this on the calculator, we get a value of 33 for y or fx. Similarly, when we solve for f of -2.4, this would give us a -32 value for fx. Now when we use these values, when x is -10, y is 0.93. So we are on the left side of the vertical asymptote, it's 0.93, whereas when x is -2.6, that is on the left side of the vertical asymptote, however very close to the vertical asymptote, y value is a very large positive value that would show the end behavior near vertical asymptote on the left side going upwards or towards the positive infinity of y value. We can connect these two arrows to complete the left side of the graph. On the right side of this vertical asymptote, point for x we have is -2.4, for which the y value we got is a -32. That is a very large negative y value, so that would be somewhat here. Now all we have to do is just connect the arrows, but make sure pass through the y and the x-intercept, and this is how the graph is going to be seen for a linear over linear function. Once we get the final graph, we can write on the key characteristics. So domain for such a graph would be XER, where x is not equal to the vertical asymptote, and that is -2.5. Range is YER, where y is not equal to the horizontal asymptote, and that is 0.5. We can write down the x and y intercepts if we want here. However, we have already found those x and y intercepts earlier, so we need not mention them again. Important thing that has been left out and has not been mentioned yet is the positive, negative, and increasing, decreasing intervals. So the positive interval we see is going to be from negative infinity to negative 2.5. Reason being is that the graph is above x-axis. So this whole section is above x-axis, and we notice here that the graph surpasses x-axis again after x equal to 4. So there'll be two positive intervals in this case. One is negative infinity to negative 2.5 up till here, and then after that 4 to positive infinity. So we would put and 4 to positive infinity. When it comes to negative interval, the graph is below the x-axis from negative 2.5 to 4. Third important characteristic is increasing interval. We notice that this graph is increasing from left to right in this section also, as well as in this section also. So it is a never decreasing graph. It's always increasing. However, there is a break at the vertical asymptote that we have to mention. Therefore, we would write down negative infinity to negative 2.5, this graph is increasing. And again, it increases from negative 2.5 to positive infinity. When it comes to decreasing interval, since there is no decreasing interval seen here, so we would write down none. And this is how we make a graph of a linear over linear function and write on its characteristics as well.